Hello guys. Today I will talk about a problem I find quite interesting on Leetcode. There is a five tool student attendance record tool. It is a hard problem, but if we think about it carefully, it is not very hard. So first we will read the description. An attendance record for a student can be represented as a string where each character signifies whether the student was absent, late, or present on that day. The record only contains the following three characters: A mean absent, L mean late, P mean present. Any student is illegal for an attending a what if they meet both of the following criteria. One, first, the student was absent for strictly fewer than 2 days total. It means the student can only absent one or zero in the attendance record. First, second, the student was never late for 3 or more consecutive days. Okay, so given an integer n returns the number of possible attendance record of length n, then that makes a student illegal for an attendance what the answer may be very late, so return it in the model. Okay, so we So we have a number n and we have to return the number of illegal record. Okay, so we we will talk about uh, uh, an illegal record. Uh, a record can be like that, right? P L A P. It is like and it is an illegal record because it had only one A and one L. So it will show an illegal record, but it is not anymore. Why? Because we have three L continue. uh, We have two L in a row. It will show it will show an illegal record because we have two A. Right, okay. So first, we will think about brute force native solution. Okay. Um, I think we need to will have a function, or we will check. We will generate on a illegal record and count. There are how many record, right? It is like we have to build a record from start from one to n. So mm, to do that, I think we need to use a recursion. Okay, we have a function dfa we will firstly we will see parameter I integer. Right, when we build uh, uh, an record, we have to build from I to n, right? Okay, if I equal n, we will return one. It is the base case. If we can generate to n the valid variable record. Okay, so we need to we need one more parameter count like the count like mean the if the count like is the like right before our position our I position if we are here we are here with the uh, L right when we come to E position here. So the count late mean can be two. We only need to know that. We don't need to know the L before because it doesn't affect our illegal record. And if we are here, so the count late will be zero. Okay. And we also need one one more parameter is the count up up best count absent because we can only absent fewer than two, so it will be the own absent before I position. Okay, so now if I think we count, so if we in one position we can put it P or L or A, so it will be P if we here P here, right? P here. We will write the we will move to the next step at let one, and because we are on P, so next step we'll have calculate zero and count absence here. This is the same, right? Okay, so how about L? We can only put an L when the count less less than two because it it is two and we put an L here. We will have three L in a row, so we need to check if count late less than two. We count it is not it is not zero anymore. We have L here. We will calculate but one now absent is the same, and we can only mm, put an a if the count if the count uh, send less than one. The count lay also is zero after a, right? And count send will be one. Okay, and we will can count. We need to make code to to have the recursion here. Recursion another. So here we will return the from zero to zero and zero, right? From right. Okay. In the time complexity of this solution is power 3 of n. It is terrible, and of course it cannot work in that for this problem. But I think it is a good start. We need to do from the simple to more more complicated. And here, I think everyone of you can solve can make a proof of solution like that, right? Okay, we have to run to check if anything wrong. Okay, we also our solution we headable headable with a small input. Yeah, of course, if we make it if we can we got time limit the 3 power 1,000 I think 10,000 got okay we got time limit here, so I think so we will think more faster way. I think to solve this we will look at the solution here. And, we can check. I want to go step by step, small steps, so we can understand how to solve a problem similar in the future. I don't give you the solution at first. I need to think, right, mm, sense, and you can see. I think you also get the result because we repeat the step many times. We have yes here 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 You can see many steps we repeat here. So I think so. It is reasonable if we think about getting the result mm, to save our time to because we have because we have three parameters, so we need to make uh, uh, three dimension slide to set the result, right? And if you look at it more carefully, you can know that the calculate cannot bigger than two, and the count absent cannot bigger than one, right? Because we check it here, so we can have the number here. So we will we need to check it here. It uh, uh, I will show you how to use get in the solution like that in it in a problem like that when we have native brute force solution we can think about it. It will be work um, because I'm able to return it. It is very simple and here when we bring it out so we should check if it works. But yes, it worked well and the because when we check with a big bigger number. Yes, the number the result is wrong because we haven't modulo it by uh, 10 million 7 here. Mm, but we know with at least we know it we don't get time limit and it can work, right? So to to show to finish it how long we need to use modulo. I want to talk a little bit because about the reason why it will be work because we have checked the case so time complexity of it will be how um, and multiple three multiple through um, it equals six and also when right. But if he recursion solution so it in not the best. We will talk about iteration solution later. but now we need to check. Need to okay. We need to not here. Okay. Yes. So it work. It the so we submit to check it with the only solution. Okay. So this is one solution for this problem, and it is the mission the task for you. You can you change it to with on your unrecursion solution. We will give we will give the a look. We will iteration to solve the problem. Can you do it? And with we also don't need uh, ON for survey complexity. We can solve it with only constant space. Okay, I have to prepare one example here. Yeah, you can make DP memory. The PK one. I think it is similar to the application problem, but we try to use three for loop. It means six and it means oh six and to find the problem. Okay, I think you can understand it well, right? Because today I uh, I don't want to wait. I mean, today I want to talk about uh, another solution, a more beautiful solution. I find it out myself to see when I solve this problem. Mm, it the period one we can solve with O six and time complexity and O one space. Uh, the solution I gave you had not the O1 space, but you can do it yourself. Uh, anyway, so I had thought about one solution with only ON time. And so let's invent a little bit about mm, the process when we build our solution. Okay, I think when we when we are building the code tendency record, we will have three three status, right? One, we are here with p in the end of the record, with now of the record, and I in the record, and we it of course where we have some steps before after it, but now we are at the high position, so I will call it p. Yeah, it is number of way we can build the with the number of way we can build a record name high with p in the end. Yes, similar for L in A. Okay, so we have to find the mm, general way to make to find every PI in my when we are at position high minus one um, minus one. We also have three steps. It can it is the EPT EPT plus one or maybe L minus one or I, right. Yes, so if we are here, we can put all another P code, and we are here. We can also put another P, and if we are here, we can also put another P. So our P, so our PI can make PI plus one plus, right. CP it is it is reasonable to for you to understand it, right. In the second, how about LI come back to this with the okay with the a bit tricky, so we will go to A first. If we can only have one A in the record, so if we are here, we need to know if there is any I and any A before P, and if we were here, we need to know have only have any A before but if we have an A, we can make another A here, and of course we can if we are if we are at A in I minus one position, we cannot put an A here. So let let take another another step. We will build another step with hero A before hero A before P. Thì activity P thì zero A hai thì you make another step thì zero A or L. So come back to our P zero A hai. Like our thinking process about normal P I here P zero A I can equal P zero A one plus L zero A minus one. Because when it is reasonable and it is the tricky part from L zero A I. So because we can only have two L in a row. So let's think about the process. If we are here with one P, we 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 can put L here, right? But if we are here with L, we don't know if we can put L here or not because it can L or P here. So we need to come back two steps. So we need to come back the two steps. Okay. Okay, sorry guys, we can come back. I just have a meeting. Okay, hmm, we are talking about L01, right? L0A, L0A, because we are in position L, L here, we don't know if we can put one more L here or not, because maybe we can get another L here, right? Okay, so we think about is this position I to I minus one. I think we can try the position I minus two. Yes, because if we are here I minus two and something here with our position. Yes, so if we are at P, at we are in P minus in position I minus two. So we can have two K P L or P L L. It on work right. So we will minus P O A minus four multiple two and if we are at if we are L at I minus 2, we have only one way to have an L at here, right? It is LPL, not LLL, because we have three L in a row. So we have three 0 L 0A. So okay, so come back to our A I, because we have 0A before P and 0A before L, so we can put any A here, right? So how AI will equal P0A and not and L0A 1. Okay, so come back to our L, and the last one we have to solve thing with same rule set with L0A. If we are at position I minus 2 here, how many uh, how many uh, how many way we can get to Li? So if we are P, we can have three k P P L L P A L or P P L, right? But we have to think we have 3K, but if we have I here, we need to make sure we have 0A before, right? So if in line we have two step P L L or P L and one more 0A 0A before P A and L. So if in line we have P um, so we have P minus minus 2 multiple 2 at P O A P minus 2 and with with A. If we have A at P minus 2, we can get L P L I by A P L or A L L, not A L, right? Because you have only one A in the record, so is A that I A to equal to, and our last one L here, if we add L I minus 2, we can get it we can break the LA by L LP L, not L L, right? LP L, LP L, and same FP 0 here, A L. So we have uh, L 1 L, and L 2 L, L 0 A, and L 2. So we have all thing all the formula we need to solve our problem. We come back to uh, code here. Okay, first we need mm, we need to make the file we now A T 0 A no 0 A. Yes, we also need to check the base page if one we need to return to for um, we need to define the base page to one to 0 to 1 to 0 is I think for green we are easier to think and it we need to select one here easier to think easier to just write code P1 only one one P2 P2 at 3K what 3K is the IP LP and PP right so the same for yeah and so we how about I only 2K not AA mm, P 0 P 0 A P 0 A we have P 0 2 we have 2K PP PT PL and LP the same for L okay so we have our base case um, our solution um, or P I or P and one yeah, same here you can copy here P I or P um, if we now uh, P0I if we now 0I I need to tell you the this back track effort. Okay, when we done, we will return sum up the what you know name what I am by. Okay, I think uh, yes, because we okay, so let's see. We have something wrong here. Uh, uh, no, it should be okay. I'm sorry. Sorry, we have something wrong here. It should be away you know. Uh, it did not theology. It is wrong with the yeah, because now some mistake. Um, let's see, we have to yellow idea here. Okay. Oh, something wrong here. The magnet blue. Uh, okay, I'm sorry with my mistake here. I think it should be uh, P P O A L O A. I'm sorry because it did not the logic. It's just my mistake when I realized we have P zero idea. We have P L or P L and then we S L here we have L here only one. So it should be two. So, okay, and now if you will not, okay, I will rewrite it to make it easier to see. Okay, if you look at it a little bit, you can see A and P0I is the same, so we we can remove it and change on T0A to P2A. I, 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 we have I we have idea and manage it P in T0A remove the text. So it will be go, uh, but it will not work with the late ledger number because we have not moved below. Okay, so we can try the biggest number. Mm, mhm. Yes, so we try to submit it. Yes, it should work, but still low, low because a bit slowly because we use too much space here. But if you note, we only care about one and two step before every of this slide, so you can review it. And I also have a sample for you. Uh, yes, almost the same, but we only set two steps before change it up after I follow. Okay. So our solution work correctly well here, and of course you can read the editorial to find some to uh, to read our solution. What I think might be my solution here better to understand and get best practice on tells it is two multi-one domino shape and domino shape. Uh, and of course, my and one more view, my solution is not the best one. As you can see, we have one better, but in the same logical thinking, but it is a bit harder to expand than mine. If you view 1, 2, 3, 4, 5, 6, convert IQ 1, 2, 3, 4, 5, 6, 7, 8, more than two variable. Okay, So see you. Thank you guys for watching, and see you later. Love you.